Welcome to qnawire.
The storage capacity of a capacitor. So it is using PET film, polyester film, as a dielectric, and we're told that the capacitance is 3,000 Faradays. That is a lot, and that it is supposed to be operated at a voltage difference between its two terminals of 2.7 volts. So our first goal is to figure out the electrical energy stored in this capacitor. So we'll use the handy-dandy formula, U equals 1/2 CV squared. If we use the capacitance in Faradays, and of course the voltage in volts, that should give us the energy in joules. What we get, let's see. Is about 10.9 kilojoules. I'll just say 10 to the third joules that we can store in this capacitor. Now, one of the things of interest in developing batteries is not just the potential energy that you can store, but the energy density, which we will take here to be U divided by the volume of the cylinder. Some tables list energy density as U per unit mass because the weight of your battery or storage device is problematic. But we have a cylinder, so the volume is pi r squared times the length of the cylinder. We have the radius in meters and the length in meters, so we can find the volume fairly readily. The unit should be cubic meters. Now finding the energy density. The energy we just found divided by the volume of the cylinder gives us quite a bit of energy density of the order of 28 megajoules per cubic meter. I will write mega as 10 to the 6th. Does that seem reasonable? Let's figure that out. We will go look and find some other specifications for PET film or polyester. And what we see is that PET has a relative dielectric constant of 3.3, meaning 3.3 times more than air. It has a dielectric strength, which tells you the maximum electric field that can be going into the material without it breaking down into individual ions. That is 6 times 10 to the 7th volts per meter. We can now calculate the same energy density in a different way. That energy density is 1/2 times the dielectric constant times the permittivity of free space times the maximum electric field squared. Putting that all together with the permittivity of free space as 8.85 times 10 to the minus 12 in good old SI units. what we wind up with is the energy density is, let me check that one more time, is about 53.6 times 10 to the third joules per cubic meter. Okay, so comparing the two, the energy density that we found is enormous compared to what we would expect for this material. So either this capacitor, they gave us some wrong figures about it, or there's something else going on in that capacitor that we don't know about besides the PET film.